Welcome all. Today we will understand how to build logical functions using multiplexers. This is nothing but a 4:1 MUX. So FPGAs are called field programmable gate arrays, wherein inside FPGAs we can have multiplexers to realize logical function, and as you know, any combinational function can be implemented using multiplexer alone. So that is the reason why we have adapted multiplexers for FPGA. And if you take this 4:1 multiplexer, it has two inputs, A0 A1 and one output. Similarly, if you take another multiplexer B0 B1, and that is going to have an output. If these two outputs have been coupled to the third multiplexer, which is 2:1, we can easily build a 4:1 multiplexer. So this logic block similar to this were used in FPGAs such as Act 1 and Act 2 type of FPGAs. So with this multiplexer alone you can build combinational circuit. When you include, so this is the block diagram view. When you include this, we have 4:1 multiplexer, wherein the output of multiplexer is fed to the flip-flop. So with this you can use to realize what is called as sequential circuits. We will take up an example to understand this. As usual, F1 is nothing but we will take A bar, B bar, C. So A bar, B bar, C, A bar, B, C bar plus AB. This is the function we have to realize using 4:1 MUX. So it's a 3 variable function A, B, C, and if it is 3 variable, then you can have 8 different combinations. A equal to 0, B equal to 0, C equal to 0. We don't have that minterm here, so it is equal to 0. A bar, B bar, C. So that minterm is required. So take this and put a 1. We want this minterm as output, and finally we are going to sum it up, and this is in the form of SOP form. The third input is A bar, B, C bar. That is also required. So take the output as equal to 1. We want that minterm, so it should be 1, 0, A bar, B, C. We don't want that, so take it as 0. A, B bar, C bar. We don't want that minterm, so you can leave it as 0. A, B bar, C. We don't want that minterm, so it can be equal to 0. The last two cases, A and B equal to 1, and C bar and C. We want A and B to be in true form. So here A and B is in true form. So you will have to make output equal to 1. So partition this into 4 rows. This table is divided into 4 rows. So when you take up the first row where C value is 0 and C value is 1, F value is 0 and F value is 1. So you can take the C value as it is for F. C value as it is for F. So assign it as C. The next row, C is equal to 0 and C is equal to 1. When you take the output, F is equal to 1 and F is equal to 0. So it is nothing but C bar, because C is complemented here. C is complemented to 1 and 1 is complemented to 0. So take it as C bar. The third row, so first row, second row and third row. The third row, the F function doesn't depend upon C. F value is equal to 0. So take it as 0. And the last function where a, the fourth row, when a value and b value is in true form, the output is invariably equal to 1, so take it as 1. So what you do is, the 4:1 multiplexer has two select lines, so these two select lines are taken as a and b input. The third input, C input, has to be taken from this table. Directly the first input of the multiplexer is C, the second input of the multiplexer is C bar, the third input of the multiplexer is 0, and fourth input to the multiplexer is equal to 1. If this is the case, this F1 is going to be realized. So this is the way the FPGAs are using multiplexers for realizing logical functions. And thank you all. Thank you.